This is the PhET wave on a string simulation, and we're going to use it today to make a wave and to make some changes to the wave's properties so we can analyze how they're related. In this video, I'm going to quickly show you how to use the simulation for the activity that you're going to do. So when you open the simulation, you'll have this screen, and you can see this string that the wave's going to travel across, and it's clamped at both ends. Just note that the string is made up of that chain of red particles, and some of them are highlighted green, and that's going to make it easier to see how they're moving relative to the direction of the wave. The first thing that you should do is to change the end of the string from a fixed end to no end. So you now have a magical string that's disappearing out the window. Next, you'll need to change the damping to none. If damping is on, the wave height will decrease as it moves from left to right, and it's just going to make it a little bit harder to do this activity. So we want to set it to none. There's a setting as well for tension, which should stay set to high. You can play around with the tension at the end, but don't change it while you're doing the activity, as it'll make it more difficult to take measurements, and it needs to be constant. It needs to be the same throughout the activity so that your results are useful. Right now, you can manually create a wave by moving the clamp on the left. Or you can change the setting to pulse, but we want a continuous wave, so we need to set it to oscillate. So remember, if something is oscillating, it's moving back and forth in a repeating way. Now we have a wave, we need to take some measurements of it. The simulation has a ruler that we'll use for this, so click on the ruler button to turn it on. You can drag these rulers around the screen as needed. Now it's practically impossible to take any measurements while the wave is moving, so I'm going to hit pause to freeze it. Now I need to measure the wave's wavelength. So remember, wavelength is the horizontal distance between 2 points of a wave that are in phase, so 2 points that are in the same part of the cycle of oscillating up and down. Now the easiest way to measure wavelength is to just measure from the top of one wave, which we call the crest, to the crest of the next wave. Okay, that distance is the wave's wavelength, and it's measured here in centimeters. And you should record that measurement in the first row of the table on your worksheet. We're now going to change the wave's amplitude. So we're going to increase it from 0.75 centimeters to 1.25 centimeters as per the instructions on the worksheet. I'll do that by moving the amplitude slider at the bottom of the screen . And you can see that's increased the up and down movement of the oscillator that's creating the wave. And this has made the wave taller. It's given it a greater amplitude. So again, we're going to use the ruler to measure the wave's wavelength. Again, measuring from crest to crest, and you should record that distance in your results table. For the next adjustment, you're going to be changing both the amplitude and the frequency of the wave. And frequency is how we describe how many waves are passing each second, or how frequent they are. For frequency, we use the units hertz, and that just means how many waves there are each second. There's 6 different combinations of amplitude and frequency that you're going to test, and they're listed in the table. The table also has a column for wave speed, but you'll calculate that after doing the measurements of the wavelengths.